Okay, so we're going to mix two lessons. We're going to talk about continuity just for a little bit. We're not going to have a rigorous definition of continuity today, but we're just going to introduce it, and then we're going to talk about piecewise functions. So continuity at this level, as far as we know, is if you can draw something without having to pick up your pencil, then it's continuous. So continuity, or something is continuous if you can draw something without having to pick up your pencil, because we do graphs in pencil. So, for example, our examples like lines, that's continuous. Parabola, that's continuous. Cubics, that's continuous. Sine, well, we'll see, sine wave, that's continuous. Cosine wave, that's continuous. Exponents, that's continuous. Logarithms, that's continuous. What are some of the discontinuous? What are some of the discontinuous functions? Well, what we've been studying recently, the rationals. So for example, asymptote, and I have to pick up my pencil and start over the next branch. Another thing we're going to see is tangents. This is tangent. Pick up my pencil. Pick up my pencil. So let's see it. So it is a function, but it's not continuous. It's not continuous. Okay, let's move on. So let's talk about some different types of let's talk about some discontinuities. Let's move the camera over a little bit. Sorry, I'm just reading off my script that I made for myself. Let's explore the function y equals x squared minus 4 over x minus 2. And so you look at that, you say, okay, Mr. Eller, that's part of the stuff we've been doing, quadratic over linear. But when you put it in Desmos, it just looks like this. It looks like a line. You're like, what's going on there? Well, you look at that more closely and go, you know what? X minus 2 times x plus 2, and this x minus 2 cancels out, and I'm left with what looks like a line. Now, it's not a line. It is a line, but at x equals 2, we don't have an asymptote, we have a hole. Okay, can you see that up there? Yeah. So whenever there's a common term in the numerator and the denominator, that's we don't have an asymptote, that's a hole. So if there is a common factor in the numerator and denominator, there's a hole. There is a hole. So that's one form of a discontinuity. You can try it on your own. Yeah, you can try it on your own. For example, how about this one? Y equals x to the third minus 1 over x minus 1. Now we know that x minus 1 is a factor of x cubed minus 1. So let's see what we can do. Take a second. Okay, we're back. Well, I'm going to use, you can either go old school or you can use synthetic division. Because my lead term in the denominator is 1, I'm just going to quickly do synthetic division. 1, 0, 0, negative 1. So I have 1, 1, 1, 0. Nice. So this ends up being y equals x squared plus x plus 1. So you're like, it's a parabola, right? Let's sketch this parabola. Well, I know that the axis of symmetry is negative b over 2a. So it's negative b over 2a, and therefore I know the turning point, right, because I studied parabolas and I know it. You have a couple, once again, any way you want to figure out how to graph this parabola is fine with me. I'm just, so what do we have here? We have 1/4 minus 1/2 plus 1. Well, what's that? Let's see, 1/4 minus 1/2. -4th plus 1, 3/4. 3/4. Sorry. And now I can quickly make a sketch here. I know, right? So I know what this parabola looks like. This is the turning point. I know this is the y-intercept. And I know it's a smile. But where's the hole? Right here. And so that's our new kind of function. Right? So it's a parabola with a hole. Can you see that? Yeah, it's a parabola. Once again, this is the axis of symmetry. This is the turning point. That's the y-intercept. And that's my hole. Now, my question to you is, can I remove this problem? Can I do something? Can I do something to? I don't want something. I don't want a discontinuity. I want my functions to be continuous. So because I want to use all real numbers. So the question is, can we remove the problem? So let's move my desk. Sorry. So the question is, can we remove the problem? Can we remove the problem? That's the question you asked when you get questions. Can I remove the problem? And let's see. So let's go through a couple of these. Let's start with y equals 1 over x. 1 over x clearly has a discontinuity at x equals 0. Is there anything to remove this problem? Anything to do? Because some of you might have looked at those past ones and say, hole? Like, can we just, put a value there? Well, in one second, give me a second. Can we fix this? No. So, no. For this, no. But, with y equals x squared minus 4 over 2, x minus 2, and y equals x cubed minus 1 over x minus 1, the answer is yes. The answer is yes. And what we're going to do is, we're going to say that these are removable discontinuities. We can remove the problem. Therefore, they are removable discontinuities. Well, what are we going to do? Well, we're going to redefine the function so that I use all the real numbers. So let's take this first one. We're going to say that y is equal big brackets. Now, you might use f of x. It's fine. It doesn't really matter now. X squared minus 4 over x minus 2 for all reals when x, as long as the x is not 2, but let's go back. What would be nice to be here? And you say, oh, you know what? What is the value of this function when x is 2? Well, it would be nice if it was at 4. If the function was 4, then I can remove the discontinuity. Well, you know what? I've removed the discontinuity. I've expanded my domain or my function. Once again, when x is everything except 2, this function is fine. When x is 2, the function is 4. Let's continue. What do you think about the next function? Y equals x cubed. Y equals x cubed minus 1 over x minus 1 when x is the reals and x is not 1. Well, I want to remove that discontinuity. What do you think? What do you think should go back in the parabola? What do you think? What was the equation of my parabola? X squared plus x plus 1. At 1, the function would be 3. So, let's put that here. When x equals 1, let the function be equal to 3. And what I've done is I've removed the discontinuity. It seems weird. It's like negating a It seems like negating a negative, but that's the idea. So the question, is it a removable discontinuity? Now, that's really not what I want to focus about today. I'll ask you some questions in the homework, but I want to focus on this thing that I just wrote. What did I just write here? Well, this is known as a piecewise function. Piecewise function. What is a piecewise function? A piecewise function is a function that has different rules over its domain. A piecewise function is a function that has different rules over its domain. Right? So, for example, let's start with let f of x equal x squared when x is greater than or equal to 1, equal to 2 when it's greater than 1 and less than or equal to 2, and negative x squared plus 4x plus 2 when x is greater than x is greater than 2. Actually, let's take this equal sign out. So it's greater than or equal to 2. So what we see here is we have a function, because every x value is going to one value in the range. We don't have any overlap. Be careful of overlap. You say, okay, this is a function. But once again, it's my total domain. Every x value is going to assign one y value. That's fine. How do we sketch this? Let's do it by hand first, and then I'll show you how to do it in decimals, and I'll show you how to do it in your calculators. So let's see what's going on here. I have my axis. Now what I see here is, I have these fences. So I want to know what y to the x squared is. I know what that looks like, right? But I'm going to stop at 1. Kind of like the first region. So let's put a red fence. Once again, you're using pencil. You can draw this in if you want. I'm not drawing an asymptote. I'm just separating the region off. So we can see that I have x squared from x is less than or equal to 1. So it looks like a smile, and then it just stops. Okay, now I apologize. So the question is, what is this point here? Well, at 1, that's 1, 1. Okay, next. The next rule says the function is equal to 2 between 1 and 2. Well, I know that's a horizontal line. But I only want to start my horizontal line at 1 and end it at 2. In addition, I'm not including 1 and 2, so I'm just going to have an open circle up here and draw it over to my other open circle at 2. And that's the next fence. That's the next fence. Maybe I'll draw another fence if I feel like it. Once again, it's not an asymptote. I'm just kind of separating the regions off. Okay, well, I have one last part of the rule, which is for x is greater than or equal to 2. Well, this is it's another parabola, and it's a frown. I'm going to do axis of symmetry and turning point. Let's see if the book makes our lives really easy. And I'm going to use blue. I'm going to use blue for this. So let's see about this. Take it on the side. What's the axis of symmetry? X equals negative b over 2n. X equals 2. Okay, kind of cool. So maybe that's the maximum. We hope. IB's nice to us. What's the turning point here? Well, y equals negative 2 squared plus 4 times 2 plus 2. What do we have here? 4, negative 4 plus 8, which is 4 plus 2. Oh, did I make a mistake? Yes, it's minus 2. I apologize. This is out of the book. Sorry. Let's see. Negative 4 plus 8 is 4 minus 2 equals 2. Nice. Well, fill in the hole because this is part of the third rule. It's including in 2, so this starts there, and then it just heads down like that. And this is our piecewise function. So first question, is it a function? Is this a function? Sorry, let me close my caps, because you know I don't like that. Question number 1, is f of x a function? Well, if you see f of x, you kind of know it is. But is it a function? You would say yes. Every single x value goes to 1 and only one y value. Hey, Mr. Rattler, what about that? No, that's an open circle. It's not covered. It's not covered in the second rule. What's going on here? Once again, in the second rule, 2 is not part of that. So 2 is only going to 2 for the third rule, part of the piecewise function. Is it continuous? Is this continuous? Well, we don't have a really rigorous definition of continuity, except, no, it's not continuous. I can't draw, I have to make a jump here. The rigorous explanation is, as you approach 1 from the left and the right, they're coming to 2 different places. This function is approaching 1. Once again, as you approach negative 1, this y value equals 1, but from this way, y equals 2. Because they don't match up, that's a proper definition of discontinuity. But we don't have limits yet, like we don't know that stuff yet. So you can merely say, oh, you know what, I have to pick up my pencil, or there's a jump. Is it a removable discontinuity? No, it's clearly not a removable discontinuity. No. Is it removable? Once again, can I get rid of my problem? No. And we know that. Because it's a jump. Okay, let's move on. That's how you're going to do it in your calculators. And actually, I looked it up for all the calculators. So for Desmos, you're going to put in like y equals x squared, no space, squiggly bracket, x is greater than, equal to 1. You will see this like, it becomes like greater than or equal to 1. Oh, I'm sorry, less than, I apologize. Let's see. I apologize, less than. You have to type in less than symbol, equal symbol, it suddenly merges together. Next line, y equals 2, no space, squiggly bracket, 1 less than x less than 2, close squiggly bracket. Third line is obviously y equals negative x squared plus 4x minus 2, no space, squiggly bracket, x is greater than, equal 2. How to do it in the T-Inspire? Now, this is really cool because there's a button on your calculator. Let's turn this on. The air conditioner's not on. If you go to your graphing calculator, right, and you go to graph, and you do the tab, and then you go to this button right here. See this button here? It actually has, like, you can either do 2 or 3 equations. So it allows you to put the equation in there, and it allows you to put the domain. So, for example, you're going to put in, so you're going to do You're going to do like B, you have your B, and you're going to choose your graph, and then you do tab to get the equation. This is like y equals, and then you're going to do that button next to, where's the button? It's next to the 9. Push the button. This is the button next to the 9. Button next to 9. I'm turning the air conditioner on, sorry. Oh, sorry. And then it looks like this. And you're going to type everything in there. Now, the TI-84 is interesting because that's why I don't want you to have anymore. The TI-84 expects you to understand inequalities and logic. So here's the thing. You're going to do the y equals button, and then you're going to have that slash y1 equals, you're going to do, so for example, x squared / open bracket, you're going to do x second math. Yeah. And then when you see that, you're going to see the inequality symbol. 0. Now, so the math has less than, greater than, less than or equal to, greater than equal to. Here's what I discovered. So you can't just type in. In Desmos, you can type this in, and in T-Inspire, you can type that in, but you cannot type that in the TI-84. What you have to do is understand. You have to understand that, like, for example, 1 is less than x is less than 3 is actually 1 is less than x is less than x is greater than 1 and x is less than 3. And so what you have to do is you have to go to logic and put that and in. That's why they've been training you all these years in the math classes, all that, compound inequalities. We were just training you to program. But the programmers now have done it for you. So you need to understand that this is x is greater than 1 and x is less than 2. I'll just say it again. The reason we were teaching you all that was so you could do programming, but you don't need it anymore. Let's move on. So, and if you have any math questions, calculus questions, please ask me. Let's continue. Express y equals absolute value of x as a piecewise function. How do we write that as a piecewise function? How do we write that? We can, how do we break it down into maybe 2 parts? Some of you are thinking, I want you to think about it. Okay, we're back. You look at the graph. Some of you look at the graph of an absolute value function and you say, oh, you know what? That's the line y equals x, and this is the line y equals x. You know what? Let's break this down. Y equals x and negative x. So when is the line y equals x? When x is greater than or equal to 0. When is the line y equals negative x? When x is less than 0. And so we've created a piecewise function. Kind of interesting. And we can say, this probably was necessary because maybe you couldn't put absolute values in older technology, but now we can put like ABS. So maybe this was the point of all this, just for coding. Maybe older programs could do ABS for absolute value. What's next? I'm sorry, Copy the question, or take a screenshot. Okay. So the question is, a cell phone company uses the function below to determine the cost C in dollars for G gigabytes of data transfer. So C of G, it's a piecewise function, and it's $25 if you use between 0 and 2 gigabytes. And the cost of the gigabytes is $25 plus, how much is that? 10 plus 9 minus G. I'm sorry. Yeah, the cost for G gigabytes is $25 if you use between 0 and 2 gigabytes. The cost for G gigabytes, if you use greater than or equal to 2 gigabytes, is 25 plus 10 times G minus 2. So the question they would just want to know is, find the cost of using 1.5 gigabytes of data and the cost of using 4 gigabytes of data. We can graph this, or we can just figure it out. We just know, so C times 1.5 is equal to, well, where is 1.5? Which rule do we use? We use the first one. So if you use 1.5 gigabytes of data, you only have to pay $25. But if you use 4 gigabytes of data, you have to pay, 25. You're in the second rule. 25 plus 10 times 4 minus 2, which is 25 plus 20, which is $45. Let's make a sketch of this. Let's make a sketch of the graph. We know that, but let's get our ruler. We know that it looks like, well, you know what? You can do it like a full graph, or you know what? If you have to make a sketch and you know that you're only in the first quadrant, I'm making this the focus point. So let's see what's going on. I know from 0 to 2, it's 25. Here's 25, and open circle, to 2, 25. What's happening at 2? Well, at 2, so let's take a look at this graph. Let's manipulate this line. Not manipulate it, but just rearrange a little bit. So what do I have? I have 10G. 10G plus 5? Minus 5? No. Let's see. 10 times 2 is 20. 25 plus 5. Nice. So we know that it's a line. We know that it's increasing. When G is 2, this C of 2 equals 25. So I can fill in the hole here, and I know it's up like that. And so this is my piecewise function. This happens in a lot. This also happens for those of you in your science classes, for example, like water heating. It goes there and then it goes up, and then this might look like the graph of a function is defined by. Sorry, let me get my script. It's defined by f of x is equal to 2x plus 1 and k minus x. And 2x plus 1 is for x less than or equal to 2, and k minus x is x greater than 2. So the first question is, what are they asking us to do? If k equals 8, is it find the range? Find the range of f of x. Okay, let's make a sketch of this. Let's make a sketch. So we have the graph, right? 2x plus 1 up to 2. So I kind of know that the line is increasing. I know my line is increasing, and I know that at 2, it's at 5. I'm going to pull that out. Sorry. This is y equals 2x plus 1. It's a sketch. Once again, the line's increasing, and the y-intercept is 1. This is good enough. Okay, what's going on? So if k equals 8, I I know that I have a line, and I know it's decreasing, and actually I know that the y-intercept is at 8, right? The question is, obviously, we know where this is going in a couple of units. Is this continuous? Well, when x equals 2, this is 6. So, so I know this is y equals 8 minus x. So the question is, what is the range of this function? Well, you ask yourself, okay, those are the y values. What are the y values here? Well, if I literally move up, I'm like, fine, in negative infinity, all the way up, I'm at 0, 1, 2, 3, 4, 5. I've got 6, 7. I've got 5. Do I make it to 6? No. So the range is y is less than 6. Because it doesn't get to 6. It almost gets there, just never gets there. Last part, they want to know, find the value of k for which this function is continuous. Think about that for a second. How can I find the value of k to make this continuous? Well, easy. I need to know that k minus x equals 5 at 2. Answer, k equals 7. So if k equals 7, then f of x is continuous. Thank you. Homework is on Google Classroom.